This is a question from operating system. The following table shows the process in the ready queue and time required for each process for completing its job. This is the process and this represents the time. If round robin scheduling with 5 milliseconds is used, what is the average waiting time of the process in the queue? And 4 options are given. Let's try to solve it. So this is the process and the time associated with it. Now let's draw the Gantt chart first. So this would be the Gantt chart. Now let's write the processes. P1 has 10, P2 has 5, P3 has 20, P4 has 8, P5 has 15. And let's write the ready queue here. So initially process P1 comes. So P1 is in the ready queue and P1 is placed here. And the time quantum given is 5 milliseconds. So P1 executes for 5 milliseconds. Now it goes. So this will become 5. Now P2 comes into play. P2 execute for 5 milliseconds. Now it becomes 10. So P2 is now completed. Now we have P3. P3 execute for 5 milliseconds. So it becomes 15. Now we have P4. It executes for 5 milliseconds. We have 3 more remaining here. Now P5. It executes for 5. Now we have 10 remaining here. Now again P1 executes. We have completed P1 at 30. P2 is not needed. Now P3 executes for 5 more milliseconds. We have 35. So we have 10 here. Now 10 more remaining is there for P3. Now P4 runs for 3 more units. That is 38. Now P4 is completed. Now P5 runs for 5 more unit. So we will have, sorry, P5 runs for 5 more unit. We will have 43. So we have 5 more units here. Now P3 runs for 5 more units. We have 48. So 5 more units here. P5 completes. We have 53. Then P3 completes. We have 58. This is the execution process. Now we are asked to calculate what is the average waiting time of the processes in the queue. So waiting time of the process is equal to sum of the periods spent in the waiting for ready queue. So waiting time is equal to completion time minus burst time. So waiting time is equal to completion time minus burst time. So for process P1, this is equal to 30 minus 10 because process P1 completes at 30. 30 minus the burst time is 10, which is equal to 20. Now for P2, it is 10. 10 minus 5, which is equal to 5. For P3, it is 58. It is the last process to be completed. 58 minus 20, which is equal to 38. For P4, this is equal to 38. That is this minus 8, which is equal to 30. Now for P5, this is 53 minus 15, which is equal to 38. So the average waiting time will be the average of these 5 values. So let's calculate the average waiting time. This is equal to 20 plus 5 plus 38 plus 30 plus 38. This is equal to 131 by 5. That is 26.2. This is the average waiting time. So based on the options, option B is the right choice.